So let's talk a little bit about how to formalize propositions. We'll think about how to formalize propositions that are presented to us in English sentences. Now clearly, English is very confusing language, like many other languages, so we need to really understand how to take an English sentence and convert that to a propositional statement. So let us take a look at the statement P implies Q. P and Q are propositions that are either true or false. It is perhaps not difficult to understand that why P implies Q may be true if Q is true despite the state of P. So if Q is true despite the state of P, we can say P implies Q is true. For example, we can say if the roads are wet, it could be due to rain or it could be due to some other fact. If you assume that P is if it rains and Q is roads will be wet. So P implies Q does not rule out the truthness of Q even if P is false. Clearly if Q is false, then it doesn't matter if P is true or not. The P implies Q will be false. If both P and Q are false, which is an interesting statement, then how can P implies Q be true? It is reasonable to think that if the roads are not wet, then it probably did not rain is the same as saying if it rains, then the roads are wet. So it is reasonable to think P and Q are both false, still make the P implies Q true. Think about this table a bit more using other examples. Now, so P arrows going both ways implies that P implies Q and Q implies P. That is, these two propositions are intertwined. In this example, we can say both sides are true. If it rains, then the road will be wet, and if roads are wet, then it was rain. So we say that if it rains, if and only if roads are wet. So in other words, one condition caused the other and vice versa. So let's talk about some examples of going from English to propositions. There are a few fundamental things that we need to clarify because English and all languages are quite vague. We need to clarify a few things. Assume that P and Q are propositions. P if Q means that if Q is true, then P is true, or we can say Q implies P. So if Q is true, then P is true. If P then Q is much more straightforward. That is, if P implies if P then Q means if P condition is true, then Q must be true. So this means P implies Q. P unless Q is very confusing. So let's try to decode this English sentence to make something that makes sense. P unless Q implies that this is saying that P is true unless Q is true. So that's the same as saying if Q is true, then P must be false. So therefore we write the propositional statement, if Q is true, then P must be false. That's what the P unless Q means. So this is something that you need to really think about it. P unless Q. P is true unless Q is true. Q is true. If Q is true, then P must be false. That's what this means. And we use this as the negation. So as an example, let's assume that P is roads will be dry and Q is it rained. So we say roads will be dry unless it rained. Another way to put it, if it rained, then roads cannot be dry. So we say Q implies not P. So here's another example that can be confusing. So you look at this proposition. You cannot ride this roller coaster unless you're over 18 years or over 5 feet tall. So rather than dealing with the entire proposition, which can be true or false for a given person, we try to break down the parts of this statement to smaller things. So let's assume that P means you can ride the roller coaster. Q means you're over 18 years of age. And R means you're over 5 feet tall. So these statements can be true or false for a given you. So this confusing statement we're going to break down into a smaller sentences, because there's a lot of mental energy that we need to put into understanding this statement. So let's recall that P unless Q means Q implies not P. Because if Q is true, then P cannot be true. So in this case, if you take the propositional language and translate this sentence into a statement, what we are saying is, cannot ride this roller coaster implies not P. So can ride the roller coaster is P, cannot ride the roller coaster is not P. Unless, so not P, unless, so we are here, you're over 18 years or over 5 feet tall. Over 18 is Q, over 5 feet tall is R, so we say Q or R. So we could reduce this sentence into more symbolic notation, not P unless Q or R. But we know that from the other, recalling our facts, P unless Q means Q, if Q is true, then P is not true. So not P, so when we talk about not P unless Q means that if this is true, then this cannot be true. So that means Q or R implies not P, because we are saying this is the whole thing. If this is true, this whole thing cannot be true. But not P is P. If you negate a negation, you get the original thing back. So now we reduce the statement, which is not P unless Q or R, into something simpler. Q or R implies P. This is very clear. It says the same thing. It says that if you're over 18 years of age or over 5 feet tall, then you can ride the roller coaster. So notice how this confusing statement was reduced to a much more clearer propositional statement by using the propositional algebra. So let's talk about some of the examples of how to go from English to propositions. Let P and Q be propositions is below phrasing, P is that, and Q is it is knowing. Write these propositions using P and Q logical connectors, including negations. It is below phrasing and snowing. This means it's P and Q. Oh, it should be P and Q. So this should be P and Q, okay. This should be P and Q. Keep that in mind. I will make a change here. It is below phrasing but not snowing. So that means it's below phrasing, that's P, not snowing, and not Q. Q is snowing, not Q is not snowing. It is not below freezing and it is not snowing. So this is the negation of these two statements. So we're talking about not P and not Q. It's either snowing or below freezing or both. So this means either P or Q. If it is below freezing, then it is also snowing. So this sends an implication. So if it's below freezing, which is P, implies Q. Either it is below freezing or it is snowing, but it is not snowing if it is below freezing. So there are two statements here. Either it is below freezing or it is snowing, that is P or Q, but it is not snowing if it is below freezing, and P if it's not snowing if it is below freezing. So P implies not Q. That is, below freezing is necessary and sufficient condition for it to be snowing. So this is like saying P implies Q and Q implies P. Let's take another example of propositions to English. P is the I bought a lottery ticket this week, and Q is I won the $1 million jackpot. We want to express these propositions as English sentences. So let's take this example here. Not P means I didn't buy a lottery ticket this week. P or Q means either I bought a lottery ticket this week or I won the $1 million jackpot. So let's take a look at P implies Q. P implies Q means if I bought a lottery ticket this week, I won the $1 million jackpot. P and Q means I bought a lottery ticket this week and I won the $1 million jackpot. And we know that the probability of that event is going to be very low. P, if and only if Q means I bought a lottery ticket this week that made me win a $1 million jackpot, and I won a $1 million jackpot because I bought a lottery ticket this week. So it goes both ways. So let's take something a little bit different. Not P means I did not buy a lottery ticket this week. That means it causes me not to win the $1 million jackpot. So you could say in English, because I didn't buy a ticket this week, I did not win the $1 million jackpot. Let's take another statement like this. I didn't buy a lottery ticket this week, and I didn't win the $1 million jackpot. So I didn't buy a ticket, and I didn't win the jackpot. So this one says, I didn't buy a lottery ticket, or I bought a lottery ticket and won the $1 million jackpot. So either I did not buy the ticket, or I bought a ticket and won the jackpot. One of them can be true. So either if I did buy the ticket this week, if I didn't buy the ticket this week, or I bought the ticket and I won it. And so this sort of wrap up the understanding of propositions to English and vice versa.